Welcome back to QHSE Talks, and welcome back to our continuing Certified Safety Professional, or SSP, series. In this episode, we are diving specifically into Chapter 1 of one of the most trusted references in our profession, David Yates's Safety Professionals Reference and Study Guide. And the title of this chapter alone tells you everything about its importance. Chapter 1 is simply titled The Safety Profession and Preparing for the ASP and CSP exam. Now, what's powerful about this chapter is that it doesn't rush into technical content. It doesn't start with calculations. It doesn't start with exposure limits. It doesn't even start with engineering controls. It starts with something much deeper. It starts by defining what a safety professional actually is. Chapter 1 takes us back nearly 4,000 years to the Code of Hammurabi, where responsibility for worker harm was first written into law. Then it fast forwards to the most important turning point in modern safety history, the Occupational Safety and Health Act of 1970. And that law didn't just introduce new rules. It created a massive global demand for qualified safety professionals. Not just people enforcing checklists, but professionals who understand hazard control, system design, human factors, and risk management as a science. And that sudden demand created a critical question. Who decides who is truly qualified to call themselves a safety professional? Who verifies experience? Who sets the examination standard? And who protects the credibility of this profession on a global level? And that is exactly where Chapter 1 shifts its focus directly to the organization that now defines professional safety certification worldwide. The Board of Certified Safety Professionals, or the BCSP. And right here is the exact moment where safety officially moves from being just a job into a recognized, certified, globally validated profession.
Well, it immediately establishes the BCSP as the authoritative standard setter. I mean, safety historically can be a pretty fractured field.
Sure, you have specialists all over the place.
Exactly. You might have someone who specialized only in, say, firefighting, or another person who focused only on OSHA compliance paperwork. The BCSP's immediate presence in Chapter 1, it signals that professional safety is a discipline that demands external, rigorous validation.
It moves it out of just being a job function?
Precisely. It moves it out of the realm of mere job function and into a recognized, certified profession. They are the gatekeepers, and they're ensuring a minimum standard of competence across a, frankly, dizzying array of specialties.
So, if you're building a career in safety, these are the folks defining the standards, designing the exams, and, at the end of the day, vouching for your competence to employers.
That's it.
But the BCSP doesn't just look at classroom time, right? The real key to unlocking that certification is meeting their very specific requirements for what they call professional safety experience.
Yes, precisely. And this is where the guide really starts defining the job itself, not just the test. The chapter dedicates a lot of space to outlining 2 specific criteria for determining if your experience even qualifies you to sit for the ASP examination.
And this definition, it draws a line in the sand, doesn't it?
It really does. It delineates the crucial difference between a safety technician who might just execute tasks and a safety professional who manages systems and strategy.
Okay, so let's look at that first criterion. It focuses on the nature of the position itself. What distinguishes a professional level position in the eyes of the BCSP, because, as the guide says, a title on a door doesn't necessarily qualify you.
And that is the critical point. Criterion number 1 states this is not determined by your job title at all, but by the degree of professional responsibility you hold.
And how do they measure that? What's the test?
The core litmus test, the defining element, is the reliance placed upon you. Specifically, the source material requires the reliance of employees, employers, or clients on your ability to identify, evaluate, and control hazards through engineering and administrative approaches.
That word reliance is so powerful. It means you're not just implementing someone else's plan.
No.
You are the principal decision maker when it comes to hazard mitigation. But let's dig into that duality you mentioned, engineering and administrative approaches. That feels like the entire professional spectrum right there.
It absolutely is. It reflects the true complexity of the safety professional's role. The professional has to synthesize both. And it's probably worth breaking down what those two control categories actually mean in practice, because this is fundamental to the whole field. It's codified in the hierarchy of controls.
Oh, okay, let's do it. Let's start with engineering controls.
So engineering controls are the physical design-based interventions. These are modifications to machinery, to the facility layout, to processes, or even the system design itself. They're intended to eliminate or reduce the hazard at its source.
So, like a guard on a machine.
Machine guarding is a perfect example, physically preventing access to a pinch point. Or a classic one is local exhaust ventilation, or LEV. This is an engineering solution that literally removes a hazard, like welding fumes or solvent vapors, before it can even enter a worker's breathing zone.
And the safety professional has to understand the science behind that.
Oh, absolutely. They have to understand the principles, like airflow velocity, static pressure, duct design, to make sure that ventilation system is effective and compliant. They're often working right alongside mechanical or industrial engineers to literally design safety into the system from the ground up.
Which requires real technical depth. You can't just say, hey, put a fan over there.
Right. You get laughed out of the room.
Yeah.
You need to be able to calculate the necessary cubic feet per minute, the CSM, of air movement based on the toxicity of the substance and the size of the whole operation.
So you're applying physics and chemistry.
Exactly. This requires applying principles from physics and chemistry every day. If you don't understand how a chemical evaporates or how a sound wave travels, you can't possibly design the proper engineering control. Whether that's a blast shield or noise dampening enclosure, you have to be adept at using formulas to model these hazards.
Okay, and then you have the other half of that coin, administrative controls. These are often seen as the soft skills, but they're just as vital, aren't they?
They are absolutely vital. These are the policy and the behavioral approaches. Administrative controls include things like written procedures, safety rules, specialized training, warning signs, and management systems that are designed to limit exposure to hazards. Think about job rotation or scheduling.
Lockout to gout seems like a prime example.
The most famous example is lockout to gout, LO-TO-TO. You could have the safest machine in the world, that's your engineering control. But if you don't implement the correct written procedure, the training program, and the auditing system, all of which are administrative controls, that machine remains lethally dangerous during maintenance.
So the professional isn't just a designer of physical safeguards. They're also a designer of behavioral systems and policies. And the BCSP is saying you have to be an expert in both.
Absolutely. Think about it through the lens of, say, incident prevention theory. If you look back at Heinrich's domino theory, which has been hugely influential, it puts a strong emphasis on two things: unsafe acts and unsafe conditions.
Right.
Engineering controls address the conditions. Administrative controls address the acts. The professional have to control both, and that requires this blended application of technical and administrative skills.
So you need to be able to do both at the same time.
You have to. You must be able to write an effective confined space entry permit that lists all the proper procedures, that's administrative, and simultaneously understand the engineering controls that are necessary to ventilate that space and monitor the atmospheric conditions.
That makes perfect sense. The professional has to be the master synthesizer.
Okay, let's move to the second criterion that defines this professional level experience: the required scope of the duties.
Right. Criterion number 2. This focuses on the breadth of professional duties. It's not enough to just be responsible. That responsibility has to cover really wide scope.
And how is that breadth measured?
It's measured by evaluating the variety of hazards about which the candidate must advise and the range of skills involved in recognizing, evaluating, and controlling all of those hazards. And here's where it gets really interesting for me. This requirement basically dismisses the specialist who only knows, say, scaffolding safety, or only knows the electrical code.
It does.
The professional has to advise on a variety of hazards. That implies a holistic, a generalist approach to risk management across the entire organization. But what does that breadth actually look like in concrete terms?
Well, it signals versatility across a whole bunch of diverse scientific disciplines. The source material hints at this vast landscape. You need a solid foundation in mathematics and the sciences, physics, chemistry, human physiology, and human behavior.
And then the specialized training on top of that.
And then specialized training in industrial hygiene, which is understanding chemical dose rates, exposure limits like permissible exposure limits or PALs, and ergonomics analyzing musculoskeletal disorder risks, calculating safe lifting limits like the recommended weight limit, the RWL, and fire protection, understanding fire suppression systems, egress standards, flammability limits. I mean, the list goes on.
That level of required knowledge is just staggering. It confirms that the safety professional has to be the ultimate synthesis expert. You're connecting the dots between structural engineering, like in facility planning, chemistry, in hazardous waste management, even psychology, like adult learning theory for training.
Yes.
The BCSP requires this broad reliance because, in a crisis, you are the one they rely on to manage the entire system, not just one little piece of it.
And that reliance extends to facility planning itself. The BCSP expects the professional to understand, for instance, how processes that have noise or heat or cold must be separated from areas that don't. That is systems design.
Which falls under both categories.
It falls under both engineering and administrative controls. It's about managing the interface between the worker and their environment at the absolute highest level of detail.
So Chapter 1 doesn't just give us a job description. It defines a high-level corporate leader who integrates all these diverse fields to manage systematic risk. Okay, moving now from the definition of the professional's job to the practical hurdles. Section 2 focuses on navigating the exam, strategy for success. And the reference guide offers some surprisingly practical advice embedded right there in Chapter 1 about how to approach the ASP or CSP examination itself. This speaks directly to any learner's desire for that high-value insight.
This strategic advice is gold. It really is. Because knowledge alone isn't going to get you the certification if you crack under pressure or you just fail to manage your time. The core strategy here revolves around time management and the strategic use of the multiple choice format, and it's explicitly outlined in the guide.
The first piece of advice is pretty standard, but the context here is key. Prioritize speed and confidence first. Why is that initial burst of speed so critical in this specific context?
Well, candidates are advised to complete the items they know or can answer quickly first. This is all about momentum and maximizing your score potential efficiently. The time clock is your biggest adversary on this test.
And those math problems can eat up time.
Difficult computational problems are massive time sinks. So by quickly knocking out the definition-based or the concept-based questions, you build confidence, you secure easy points, and you bank time for the heavier analysis that you're going to need later. You're turning a race against the clock into a managed resource allocation exercise.
Right. If you spend 3 minutes wrestling with some complex formula, you might miss 3 or 4 easier questions you could have answered in that exact same amount of time.
Precisely. And that leads directly to the next strategy, which is the second pass. You go back to the difficult items, the ones that require considerable time to read, analyze, or compute. The source actually encourages going over skipped or marked items several times if you have the time.
And that's crucial for a specific reason, isn't it?
It is. It's designed to ensure you get your eyes on every single question, which ties directly into the next piece of pretty unexpected advice.
Which is the explicit permission for the power of the guess.
Yes. The guide tells you, in no uncertain terms, that if you are running out of time, you must select an answer for any skipped or incomplete item.
And they give you the rationale.
They state it clearly. This is a 4-option multiple-choice test. By chance alone, you can get 1 out of every 4 correct. And since there's no penalty for guessing or for incorrect answers, leaving a question blank is a strategic failure.
That is truly fascinating. It transforms a blank answer, which is guaranteed to be 0 points, into a statistically viable 25% chance of earning a point.
Exactly.
It's an explicit acknowledgement from the BCSP that this test measures your resilience and your strategic discipline under fire, not just your knowledge base. It's such a high-value piece of advice because so many test takers, they instinctively avoid guessing.
It completely flips the script. You have to view every blank question at the end as a guaranteed lost opportunity. If you skip 20 questions and you just guess randomly on all of them, you are statistically likely to earn 5 points that you would have otherwise just forfeited.
But the most counterintuitive strategic nugget in this whole section for me is the concept of hidden clues. What exactly does the guide advise here?
The guide suggests that, and I'm quoting here, a later item may contain the answer, or at least a trigger, to allow you to answer some previous question. This is vital information. It encourages a thorough reading of the entire test structure.
Because it's all connected.
It happens because the exam is built around a cohesive body of knowledge.
Can you give us a practical example of how that might actually play out on the exam?
Sure, certainly. Imagine you're stuck on, say, question 15, which asks for the specific OSHA permissible exposure limit, the PEL, for coal dust, measured as a time-weighted average, or TWA. You remember that it's measured in milligrams per cubic meter, but you just can't recall the exact number. Maybe it's 2.4 mg/m3. So you mark it and you move on.
Right.
Then, maybe 50 questions later, question 65 asks something like, which hazard is best mitigated by adherence to the 2.4 mg/m3 TWA limit and requires periodic chest x-rays for monitoring?
And that context immediately gives you the answer to question 15.
It gives you the answer. That's a huge tip. You're leveraging the structure of the test itself as a kind of study aid. It confirms that the professional must not compartmentalize their knowledge. Everything is linked.
And this linkage is why the guide also stresses the practical advice about calculators and math.
Yes. Candidates must know how to use the provided calculator and practice the procedures beforehand. You can't waste precious time fumbling with functions during the examination. This preparation is just non-negotiable.
I can just imagine the stress. Time you spend figuring out how to calculate a square root or an inverse function on some unfamiliar device is time you've lost on a question you might have otherwise solved quickly and confidently.
Exactly. But there's another crucial detail for the computational items. The guide explicitly notes that solutions to computational items are usually rounded.
So you should select the answer closest to your own computed value.
Right. This seems really simple, but it's critical when you're dealing with complex calculations where those little intermediate rounding steps can matter.
For instance, if you're calculating the sound power level of a noise source or the required exhaust velocity in a ventilation hood using complex equations with several steps, tiny variances in how you round could throw your final answer off by a little bit.
Precisely. If you calculate an exhaust velocity of, say, 3.95 meters per second, and the options are 3, 3.5, 4, and 4.5, you choose 4.0.
Got it.
You have to understand that the test is measuring your grasp of the concept being tested, like the application of Bernoulli's principle to fluid dynamics in that ventilation system, more than it's testing absolute decimal precision. This advice frees the candidate from that paralyzing fear of being slightly off.
The reliance on math and physics is just undeniable then. The guide confirms that competence in calculating the amount of force or understanding fluid dynamics relationships is just expected.
Oh, absolutely.
Okay.
The ability to apply formulas, whether it's for kinetic energy, work done on an object, or even simple statistical measures like mean, mode, and median, which are essential for analyzing injury trends, is a core requirement. The test strategy is all about preparing you for the reality of executing that knowledge quickly and accurately.
So to truly grasp the breadth that is required by the BCSP's definition of professional experience, we need to move to Section 3, the landscape of expertise, a sample domain deep dive. We need to look at what that variety of hazards actually looks like in practice. The source details the required body of knowledge, and by examining just 2 of these domains, we can see the sheer scope that's necessary.
These domains really are the professional safety experience, codified into an intellectual requirement. We can look at 2 crucial domains from the study guide, and together, just these 2, they account for over 27% of the total exam weight.
That's a huge chunk.
It demonstrates their massive importance and their breadth.
Let's start with domain #7, environmental management. This carries a hefty 15% weight. This confirms that the modern safety professional has to operate at that intersection of human safety and ecological health. This is where that synthesis engineer idea really emerges.
The depth of this domain means the safety professional has to be a resource protection specialist. The key topics listed here are so broad: environmental hazards, water, air, land, and conservation. The professional must be versed in major federal environmental laws that directly impact site operations and worker exposure.
Can you give us a concrete example of how a federal environmental law becomes a safety professional's direct responsibility?
Sure. Look at the Resource Conservation and Recovery Act, or RCRA. This is the key law that regulates hazardous waste, from cradle to grave.
Cradle to grave.
Meaning from the point of its generation, all the way through treatment, storage, and disposal. The safety professional is often the site-level expert responsible for ensuring compliance.
And that means they have to classify the waste.
They must classify waste streams correctly. Is it hazardous? Is it acutely hazardous? How must it be stored? What are the time limits for holding it on site? This is absolutely critical because improper waste storage doesn't just lead to massive fines.
It's an immediate hazard.
It presents immediate hazards like fire, explosion, or a toxic release, which directly threatens worker safety.
So understanding RCRA isn't just about regulatory compliance for the sake of it. It's about preventing a catastrophic worker exposure event.
Precisely. And similarly, they have to understand the Clean Air Act, the CAA. This act authorizes the EPA to establish national ambient air quality standards, or NAAQS, to protect public health and welfare.
So the safety pro has to make sure the facility isn't violating those standards.
Right. They have to ensure that facility operations, whether that involves painting or smelting or chemical processing, are not emitting air contaminants that violate these standards or expose workers to unacceptable risk. They need to manage permitting, monitor emissions, and design control technologies like scrubbers or filters.
And those are engineering controls. Bring it back to Section 1.
Circling right back to Section 1, those are engineering controls.
This really moves the professional beyond the fence line of the facility, doesn't it? They're responsible for managing the site's impact on the external environment and, by extension, protecting the local community.
Absolutely. And within this domain, the guide highlights strategic concepts like the hierarchy of conservation. This concept implies it's not just about simple environmental compliance.
It's more strategic.
It's strategic resource management, linking safety to these broader sustainability goals.
So how does the hierarchy of conservation work in a safety context?
It's a direct parallel to the hierarchy of controls that we know in safety. It typically ranks management strategies: reduce, reuse, recycle, recover, and then finally, dispose. The safety professional is expected to lead efforts to reduce waste generation first. That's elimination or substitution.
Because less waste is less hazard.
Exactly. Less waste means fewer materials to handle, to store, or to dispose of, and that minimizes hazard exposure for workers. This strategic approach saves the company money and simultaneously reduces risk. It's the highest level of professional synthesis.
It really paints a picture where the safety professional has to be equally versed in, say, toxicology, understanding how chronic exposure to heavy metals like arsenic can cause skin lesions and peripheral neuropathy as they are in legal reporting requirements. The sheer responsibility is enormous.
It is. And that breadth is why we have to now examine domain #8, training, education, and communication, which is weighted at 12.35%. This is the domain of administrative controls. It highlights the crucial soft skills, or maybe we should call it the complex behavioral science, that ensures all that technical safety knowledge is actually implemented.
Right. Safety knowledge is totally useless if it can't be taught or conveyed effectively.
It's worthless.
And this domain shows that the safety professional has to be an educator, a behavioral psychologist, and a data analyst all rolled into one. If the knowledge can't be communicated, the engineering controls can't be protected. So what are the core educational topics here?
Well, they include adult learning theory and techniques, effective presentation tools, and critically, fostering a positive safety culture and climate. The professional has to apply principles like adult learning theory, also known as andragogy, to their hazard communication.
Okay, so how does adult learning theory change how a safety professional would design their training?
It forces the professional to recognize that adult workers are self-directed. They bring vast life experiences to the table, and they are typically goal-oriented. They want to know why they need to learn this right now and how it applies directly to their job.
So you don't just read the rules out loud.
A professional doesn't just read the regulations aloud from a slide. They design training that is problem-centered, that engages the worker's own experience. For instance, instead of just lecturing on lockout-hagout rules, they'd use a practical, scenario-based exercise where the worker has to physically identify the energy sources and write the permit themselves.
That makes the training immediately relevant and memorable, which is vital for something complex like confined space entry, which requires these highly detailed, specific permits listing entrants, supervisors, and control measures.
Absolutely. And on the analysis side, this domain demands competence in data collection, needs analysis, gap analysis, and feedback, followed by assessing competency. This moves the professional beyond just delivering training to measuring its effectiveness.
What exactly is a needs analysis in this context?
A needs analysis is the diagnostic step you take before you even start developing the training. The professional has to ask, is the problem a lack of knowledge, which would need a training solution? Or is it a lack of motivation, which is a management solution? Or is it a lack of proper equipment, which is an engineering solution?
Ah, so you diagnose before you prescribe.
Exactly. If the professional sees elevated hand injury rates, the needs analysis determines if workers don't know how to use the machinery safely, or if they were simply ignoring safety procedures because of poor supervision. You don't train your way out of a supervisory problem.
So the professional uses data analysis and observation to identify the root cause, the gap, and only then do they design a targeted solution, whether that's an engineering control or a behavioral intervention like training.
Correct. The professional is constantly collecting data incident rates, near-miss reports, audit results to inform their strategy. This domain directly relates back to the criteria for professional experience in Section 1. If your professional responsibility includes implementing administrative controls, you have to be proficient in the theories and practices of teaching, measuring competence, and influencing the safety culture of the entire organization.
The reliance is on your ability to communicate complex, life-saving information.
Whether it's the specifics of the Hazard Communication Standard or the Emergency Action Plan.
This confirms it. The definition of the safety professional in Chapter 1 is one of a versatile leader who is fluent in both the hard science of engineering and the soft science of human behavior.
Yeah.
This deep dive into just Chapter 1 has vividly shown us that the path to BCSP certification is incredibly rigorous. It demands not just broad technical competence, but also advanced strategic and interpersonal skills. It truly is a synthesis role.
It is. And if we connect this to the bigger picture, the professional defined by this chapter is not a mere compliance officer or some rule follower. They're a systems architect.
A systems architect. I like that.
They are leaders who are relied upon by clients and employees for both technical solutions, like selecting the proper welding cables and connectors to prevent arc flash, and behavioral guidance like implementing an effective lockout-hackout procedure that needs to be reviewed and revised whenever procedures change, and at least annually.
And the professional safety experience criteria that are outlined in Chapter 1, they mirror the demands of the examination itself, don't they?
They do.
It's all about demonstrating versatility and holistic thinking across engineering, administration, the environment, and human factors. For example, they must understand biomechanics and anthropometry for ergonomic tasks, like calculating the recommended weight limit, the RWL, to prevent low back pain, while simultaneously mastering the complexities of electrical safety, like understanding the concepts of voltage, current, and resistance in series and parallel circuits.
And the definition that's provided right there in the text, an individual who, by virtue of his specialized knowledge and skill and order educational accomplishments, has achieved professional status in the safety field. That definition demands this wide foundational scope. They need to know the basic structure of the U.S. court system to understand legal aspects like product liability, while also being capable of calculating the kinetic energy of a moving object or the velocity of airflow in a ventilation system.
It just paints such a clear picture. Achieving this professional status requires demonstrating that you can manage immense complexity, apply scientific principles across diverse environmental and human domains, and then communicate that knowledge effectively.
Yes.
It is a credential that signifies mastery of technical analysis coupled with strategic organizational influence.
And that demonstration of professional responsibility extends to the highest ethical standard, which is also addressed right in these foundational materials. And that is holding paramount the safety and health of people, the protection of the environment, and the protection of property in the performance of professional duties.
That's the core of it all.
That ethical commitment is central to the entire professional identity established in Chapter 1. The certification is a public statement of this commitment.
That brings us to the end of our deep dive into the foundational Chapter 1 of the Safety Professional's Guide. We thoroughly covered the defining role of the BCSP, the precise criteria that distinguish professional safety experience from mere technician work, the counterintuitive strategies for passing the complex exam, including that tactical use of strategic guessing and leveraging hidden clues, and the vast terrain covered by just the environmental management and training and communication domains.
What's really fascinating here is how the criteria and the domains just reinforce the necessity of a multifaceted approach. The safety professional has to master everything from the intricacies of hydrostatic testing for fire extinguishers, a very specific engineering control detail, to the psychological principles of Maslow's hierarchy of needs to motivate safety performance, which is a classic administrative control detail.
It's an incredible range.
A certified professional must be capable of synthesizing information from engineering, environmental science, and human behavior constantly.
We hope this gave you, our listener, a shortcut to being well-informed about the initial steps and the very high standards of this extremely vital profession. It's so clear that the certified safety professional must be an expert generalist, capable of managing systemic risk across every single facet of an operation.
Indeed. The rigor that's established in Chapter 1 is the reason the CSP credential carries so much weight in the industry. The high level of job satisfaction that's reported in the safety field, coupled with the significantly higher earnings potential for those holding a CSP certification, it really shows the value that industry and society place on individuals who can successfully navigate this demanding professional path.
So, our final provocative thought for you to mull over. Considering the rigorous, required breadth of knowledge established in this foundational chapter, from analyzing environmental hazards and understanding the Resource Conservation and Recovery Act to mastering adult learning theory and calculating fluid dynamics, does the modern safety professional become the ultimate synthesis engineer, designing not just facilities or products, but entire complex, ethical, and safe organizational cultures?